So the second type of question here as application to business of optimization is to minimize costs. So here first we are to be reminded that total cost can be decomposed into fixed cost and variable cost. And then we're going to take those steps to do the minimization. The first three steps are actually just one, which is to solve for the solution of first order conditions. So here we need to take the first order derivative of total cost. We set this derivative total cost equal to 0, which is actually marginal cost, right? Because the first order derivative of total is marginal. And then step 3, we solve for Q so that the derivative total cost equal to 0 is satisfied. Namely, the first order condition is met. Then we move on to the second step, which is the step 4 here. That is to check the second order conditions. So here we need to ensure that the function that you're solving, the total cost that you're solving, is a convex function, right? So that it's a V shape, therefore there is a bottom, there's a minimum to this case. So now let's move on to example 4, minimizing costs. So you're provided with this cost function in which fixed cost is 50, variable cost is 2q squared minus 20q. And the total cost, again, is the summation of fixed cost and variable cost. That is 50 plus 2q squared minus 20q. Okay. Then let's do the 2 steps. Step 1, we need to solve the first order condition. And before that, what I suggest is you define the problem. The problem here is we are to minimize total cost by choosing Q. We can write it aside to remind you as you are doing derivative, what is the function that you are deriving over? That's the total cost function, right? So here it is the first order condition. Now let's just solve it. The left-hand side is the derivative of total cost with respect to Q. You're treating Q as X. You're treating Q as an independent variable, right? So 50 constant has nothing to do with Q. So as you're deriving this, you can disregard. And the second term, the derivative is 2Q. I'm sorry, 2 here, stays here, multiplied by 2Q. And the third term is minus 20. That's the right-hand side, equals to the left-hand side, 0. So that's 4Q equals to 20. So Q star equals to 5. So this is a stationary point. Then we need to go to the second step, which is to check the second order condition. So the second order condition, the second order derivative is now you take another derivative with respect to the first order derivative, right? So here that is 4, right? And minus 20 is derivative is 0, disregard. It's greater than 0, so your function is a convex function, and Q star equal to 5 does minimizes total cost. Here, there are the 2 major steps, right?